audible? Okay. So in yesterday's session, we are discussing how we can select or how we can select these window sizes, how can adjust this adaptive layouts. So this like in yesterday's session, we are completely discussing about how we can adjust our UIs to every screens in every type of screens like a compact or medium expanded. So many window sizes screens will be there, right? So how can we adjust those things? And without using the now host or the now host controller, how can we navigate between one screen to another screen? We are discussing, right? Yesterday we did that one. Did you all complete the task? Did you all complete your yesterday's task? Okay. So I see some of them are giving me thumbs down. Those who are not completed your task, try to do by today, like try to complete it by today. And today we will just move on with how we can collect the data from the internet. So you can see like sometimes we're opening some applications and it will be freezes, right? The screen will freeze or it is taking too much time. So all these things will happen. So sometimes when your network is too slow, it will happen. Otherwise, the code will slow. It is also happening sometimes. So today we will just learning how we can collect the data from internet or why this code is running too slow and what types of code running will be there. We can see that one. Just give me a second. I will share my screen. So my screen is visible, right? Okay. So today we will just discuss the topic of an introduction to the core routines in a Kotlin playground. First, we will just do it in a Kotlin playground. In this pathway or in this code lab only, there is another one code lab. So in that, you have to build an project or you have to build an app in a Android Studio. Okay. So this is just an what you have to learn in this code lab. You will learn how Kotlin core routines can simplify the asynchronous programming and the purpose of the structured concurrency and why it matters. So these are the two topics you will learn. We just go on with the code lab. The first topic is of synchronous code. So I will just simply explain you that what is this synchronous code means. It will the synchronous code means it will run the code line by line, like you can see here in the code, like in your screen only. They are just given some example code, the function main printline weather forecast and printline sunny, right? So it will run the synchronous code will run line by line. First it will run weather forecast, after that only it will run the sunny. Okay, so it is like you are running and it will like the code will delaying or it will be crashing somewhere in this step. You can see it will be stop running at the one step. So the next step, whatever the next step will be there, it has to be stop and it has to be wait for running the step. Like this sunny line will have to wait for run, that weather forecast has to be run. Like first it has to be run and after that only the next line will be running. So simply it is just an it will run the code by line by line. It will does not run the both the lines at a time. It is not doing that one. It is just run this code by line. So for that there are some functions or some parameters we are given. So we when we add the delay, so in that we just adding this delay. The delay is of just an adding the timings for running the code. You already know, like if your background, if your branch is of any CS or IS branches, you can know that why we given this delay, right? So we just add this delay function or the thing for like some assume that you are taking the datas from internet. So it is taking too much time for collecting those datas. So and that time we are using this like we are add this delay. Those who are Sujai batches, like for you, Sujai will take in the classes. So he will take in the classes in 15 minutes. Just wait for 15 minutes. He will take in the class. So I will just end the call here. Okay. And inform your friends, those who are not getting this information. Just wait for 15 minutes. He will take over the call. Okay. Okay.
Is my voice is clear and audible? Is sorry for some of delay today because there was some issues over here. So for the sessions it was delay. I guess this will not happen in further sessions and all. Yeah, we have already lack of time now, so we'll do fast today's work and we'll finish it off around 12:30 or 12:40 and all. So just give me a minute, guys. I'll paste the today's link code lab in the chat and I'll share my screen. So yes, I guess everyone can able to see the link in chat, right? Make sure before the session's over to note it down it somewhere else. Is my screen is visible for everyone? Yes. So today we are in this code lab, we are going to learn how to get the data from the internet and all. So in this particular part, we have, like three major code labs, one with introduction to, uh, you know, yeah, so we have, like more than three, they have given some YouTube videos, you could have watched it on your own, and we have introduction to coroutines in Kotlin Playground and introduction to coroutines in Android Studio and all, and also how we can get the data from the internet. So basically, in the today's part, as we already in the lack of time and all, so we'll finish the second and third code lab today, and we'll work on fifth code lab tomorrow. We'll finish two and three code labs today. Is that clear? Yes. Yes. So this is the most important topics in Android development. It is mm, yes, the first in that is introduction to coroutines in Kotlin. So see, when we are using an app, if it suddenly freezes, then when we click a button and it nothing happens for a 3-4 second because it gonna freeze over there. So do you feel like the app is stuck, and why does this basically happen? See, because the app is doing heavy work on the main thread. So now what is basically a main thread? It is a thread responsible for UI. If you block it, your app gonna freeze, and the users hate that. And also, so today we are going to solve this problem using something very powerful, that is coroutines in Kotlin. So coroutines helps us performing long running tasks without blocking the UI. So this is what we'll look into the today's part. So now let's understand the problem first. So basically, you see what is synchronized code means. In synchronized executions, tasks runs one after another, and also it has no skipping, no parallel work. Let's say it fetches the data and it processes the data and it basically shows the UI, where each step waits for the previous one. Now imagine fetching data takes a 5 seconds. The UI will wait for 5 seconds. That means your app will freeze. So let me give you a real life example. So when you go to a restaurant, you order a food, and the waiter says, stand here until your food is ready. You cannot move, you cannot sit, you just wait. So this is what the synchronized behavior, which is a blocking, and this is exactly what we don't want in the apps. And I guess we have most of us see when we are using the app, it gonna freeze like this. It will freeze sometimes over here. So, and also they have given some synchronized code for you to practice in the Kotlin playground. So you could have go for the not Android Studio, for the Kotlin playground, and make sure that you practice one of these code labs. And also, they have given the expected outputs. See, as you can see, the expected outputs when you run the program. Make sure you could have practiced those in the Kotlin playground, and they have also given the Kotlin playground direct link over here. You could have go through this part. Coming to next, that is asynchronous code. See, now we'll fix that problem. So basically the asynchronous code is also known as an asynchronous execution, where the tasks don't block each other, they run independently. And let's go back to the restaurant example, the same example what we have took over here right now. So now the waiter says your order is placed. So please sit, I'll call you. Now what happens? You're free, you can sit, you can talk, you can use your phone, and when the food is ready, you get notified. So this is what asynchronous behavior. So basically, when it comes to synchronous, as we discussed, so it is like a still, you can't do anything. It's like a freezing of app or freezing any screen. Your app will doesn't do anything, it will doesn't work anything for some times. So where the asynchronous behavior as things, so it can work properly, can do any other activities without any freezing and all. So in apps, in where asynchronous part in the apps, UI continuously working, there will be no issues, and background work happens separately. They will not merge or one-on-one over there. So this is exactly what we need. The major thing you have to understand here is, so asynchronous programming improves the performances and the user experience. But the problem with the old asynchronization is, see, earlier we used threads, callbacks, and all, but they were complex, where callbacks led to something called callback hell, where it is nested, it is messy, and it is very hard to read. We can't catch it up over those all things. So Kotlin introduced the word called coroutines. So this is what the Kotlin introduced the thing called coroutines. So you could have practice in the Kotlin playground. So you will get an idea how the coroutines code works and all. So this is what also they have given some of the output, expected output. Make sure to practice these things in the Kotlin playground, and you will get an idea how it works. Expectations and cancellations. Now let's talk about the real world problems. See, what if something goes wrong? What if network fails and server crashes? User cancels operations. So this is where expectations and cancellations comes in. So coroutines are just the smart, where they allows you to handle errors properly and stop tasks when not needed. For example, user opens a screen and the data is loading. When user presses back, should we continue the loading? No. Why cancel it? Because to save the resource and to improve the performances and all. So good apps don't just run the task, they also know when to stop and when to start it again. So this is what the expectations and cancellations part or the role come over here. Coroutine concepts. When it comes to coroutine concepts, now we enter to the major concept of this, or it's like entering to heart of the topic, the main part of this topic. So let's discuss the coroutine concepts in detail. So let's break down this step by step. So first we are discuss about what is coroutine. So coroutine is like a lightweight thread, but not exactly a thread. It's just like a lightweight thread where it is a cheaper, faster, and it is a more efficient. So coroutine scope is, this defines the life cycle where it tells how long coroutine should live. And the next we are going with the coroutine, that is launch versus asynchronizations, where it says two ways to start the coroutine. The one way is launching the launch, and another one is with asynchronization, where the launch, yes, where the launch says fire and forgot, where asynchronization says returns result. So this is what the launch versus asynchronization does. So use launch when you don't need the result. You could have used the launch because it will just like fire and forgot. It will not take anything into deeper and all. But when you need the output and all, you can use the asynchronizations. The next one is, the fourth one is suspend function, where this is a very important. Suspend function means this function can pause and resume without blocking thread. So this is like the magic of the coroutines. And the last one concept of is dispatcher, where the dispatcher decides where coroutine runs. Basically, see, this is a dispatcher where In the dispatcher, it has a three, that is main, IO, and default, where the main says it's for the UI thread, and the dispatcher IO goes with the networks or the database, and the default is for heavy computations and all. So we choose dispatcher based on the works and all. So this is all about the coroutine concepts we have gone over here. So basically, coroutines don't make things faster, they make things non-blocking. Yes. So now let's summarize everything what we have gone over here. We started with a problem that is called app freezing, where then we understood how synchronization code blocks the UI and what is asynchronization code improves experience. And then we introduced coroutines and we learned coroutine basics, scopes, dispatchers, suspend functions, error handling, and all. So now let me end these things with a line that is a smooth app is not about speed, it's about not making the user wait. So this is all the things we have learned into. And we could take the real life examples also, like Instagram loading posts, YouTube buffering, and WhatsApp sending messages. And also this is all comes under for the real life example. So this is what about the caroutines and some of the things in coroutine synchronization and all. So they have given the codes, and also there is no need of working these things in the Android Studio. So make sure that you can work these coding parts in the Kotlin playground. Moving to the next code lab, that is introducing introduction to caroutines in Android Studio. Now it comes Android Studio. Before it was just only for Kotlin playground. Now it comes for the Android Studio. So first they will give only for the playground, because just to have an idea about it. After, once you have an idea, once you have a grip, then you could move for the Android Studio. So Lal, before we start, let me ask you something. Like when you open an app like Zomato or Swiggy, you place an order, and then you'll see live updates like order placed, preparing food, then out of delivery and all. So have you ever thought, how does the app update these things continuously? So is it running everything in one thread? No, it is using something called caroutines with concurrency. Yes, today we are not just learning the caroutines, we are learning how to use them in the real apps. So by the end of this code lab, you will think like how it works on the real Android parts and all. So see, they have built an app called in such a way like this. So where it shows what is the percentage of player one and player two while in the running the race and all. So when it starts, what are all the things and all. So you could work on these particular areas and all. So now let's understand what we are building in this part. So basically, you're building a race app where multiple participants are running and their progress is updating in real time. Now think about this carefully, guys. So multiple runners update at the same time. That means multiple tasks running simultaneously. So this is called concurrencies. When multiple tasks running simultaneously is called, or it's none other than it's called as concurrencies. So can we do this using normal code? No, because normal code runs step by step, but here we need parallel execution, where that is where coroutines come in. So this is what you're gonna build in this code lab. I mean, what the app is you have to build in this particular way, and make sure that you are following the correct instructions while you're building these coding parts in the Android Studio. So implement race progress. Now let's implement the progress. So each runner has the speed, progress, and the state. And progress should increase over time, Now here's the key point where progress should not block the UI, and also, so when you use the coroutines, each runner will have its own coroutines, which means each runner runs independently just like a real life. So coroutines allow multiple tasks to run independently without blocking each other. It will, as I said you, it will have, or it will work the things simultaneously, or two or more the things it can do simultaneously without any breakage. And also this is what the coroutines allow us to do. So think of runners on a track where each runners runs at their own speed. So every runners doesn't have a accurate one particular speed. Each runner has a different speed on their capability. So they and also, they don't wait for each other and all. If the race begins, they will just concentrate on their part. So this is exactly how coroutine works. Start the race. Now we'll we start the race. So this means we launch the caroutines where each runners start moving. Now here is something important. When we start caroutines, we don't block the main thread where UI remains smooth and user can still interact. So this is the beauty of caroutines. So like caroutines give illusion of parallelism while effect where it's efficiently using the threads. So no need of worrying about it. They have given the coding parts and all. You just need to follow the instructions and move it properly. Say, as you can see, the player one, the race when it race start, it's been starting the graph and it's been moving. When you click on start, it goes on moving. So make sure that you are getting the same thing when you're building the things. The structured concurrency. So it is a very important concept. Now we are entering to the most important part. So let me explain you in such a simple way. So earlier with threads, we had no control. So where threads could run anywhere, it leaks memory and it also crashes the app. But caroutines solve this. They follow structure, which means every caroutine belongs to a scope. And when the scope is destroyed, all caroutines inside are also cancelled. So this is very important. For example, user leaves the screens and we should stop all running tasks. Otherwise, memories will leak and it will crashes and it will waste the resource. And so structured currencies ensures the safety, control, and the clean life cycle. And you have to remember one more thing, that is caroutines are not just about running the task, they're about to manage them properly also. So launching concurrent tasks. So now we'll move one step further. So running multiple caroutines at the same time, this is called concurrent execution. Yeah, so this is called concurrent execution. So now in our race app, we launch multiple runners simultaneously where each caroutine starts, updates progress, and it will finish independently. So now here's the important part where they don't block each other. So this is what makes app more responsive. So think it of like a kitchen where multiple chefs cooking different dishes. They don't wait for each other, but everything finishes on time. So this is what concurrency means. Writing the unit test for caroutines. So now comes something most. beginner skip, where testing carotenes is like, let me ask you something. If your asynchronization code fails randomly, how will you detect it? You can't rely on manual testing, and also we write the test. So now in testing, carotenes is a different because they run asynchronously, and so we need special tools to control execution in tests, where we control time, we control executions, we verify the results. So this ensures your asynchronization logic is correct. So if your coroutine code is not tested, it will not reliable also. And they have given the solution code, and we learned the many things which are important about the carotenes, how it works. So basically we have they have took an example of the racer app which helps over here. So this is all about the today's two code labs what we thought of for discussing. So the one more important part, that is about the, we'll discuss what the getting data from the internet deeply in the next session. So make sure to complete the two code labs what we have discussed today. Is that clear? Yes, now we'll conclude the session. So thank you one and all. Have a great day. Make sure to complete the two code labs what we discussed today. Thank you guys.